Hey guys, today we're doing chapter 9, section 5, which is on common logarithms. So this is your first introduction into logarithms, and I can tell you they're really not that bad if you understand exponential functions. So the first question on our notes is to find the inverse of y equals 10 to the x. Well, when we do that, remember that our first step is to switch our x and y values. So we have x equals 10 to the y. And then what we have to do is we have to solve for y. But we don't know how to do that right now. Well, this is where logarithms come into play. We can actually use logarithms to be able to solve this for y, which is why they're important, because they're basically the inverse of our exponential functions. So could you plug this into your calculator and graph it? No. We need logarithms to be able to graph that. So the definition is y is the logarithm of x to the base 10, or log of x to the base 10, written y equals log base 10 of x, if and only if 10 to the y equals x. So logarithms with base 10 are called common logs. Generally, we don't write a base if it is a base of 10. So this first one here, log of 5, that's just log base 10 of 5. If there's not a base written in there, you can assume that it's a common log, meaning that it has a base of 10. So, log base 10 of 5, well, if I wanted to rewrite that as an exponential function, I would know that 10 is my base, I'm raising it to the power of y, which is on the other side, okay, and that equals x. So 10 to the y equals x, the base to the other side equals x. So if I rewrote this, this would be 10 to the y equals 5. Okay, so essentially that's what you're thinking about when you have a logarithm. Now if I want to evaluate this, all I have to do is plug it into my calculator. So on your calculator, there's this log button here. Okay, log. Okay, so the log button, that's what you're going to use, and you're just going to hit that and then 5, and you get 0.69897. Okay, we'll just round that to 0.7. Okay, if I want to find the log of 9.63, I do the same thing, and I get 0.98. And if I want to find the log of 14.609, I get 1.16. Okay, easy peasy. So next up, to evaluate logarithms without a calculator, you can put them into exponential form. So there will be a no calculator portion of your test, and you just need to know how to put these into exponential form, and then you just need to think through what number, what variable would you have here. So remember, this is a base of 10. So if I were to think about it like this, and I rewrote that, it would be 10 to the x equals 100. So what would my x value be? Well, I know that that would have to be 10 squared equals 100. So x equals 2. Okay, this one here, if I rewrote that, that would be 10 to the x equals 10 to the 40th. So what is x? X is just 40. Okay, this one here, this would be 10 to the x equals 0.01. That one might be a little tricky, but you can remember that 0.01 is actually just the same as 1 over 100. So I know that if I wanted to get to 100, I would have to square it, but since it's in the denominator, that means that it has to be a negative exponent. Okay, so this would actually be x equals -2. So please, if you didn't understand that, go back and review your negative exponent rules, because remember that if you have something like this, 10 to the -2, I can change that to 1 over 10 to the 2, which is 1 over 100. So remember the negative exponents, what that does is it moves it down to the denominator or up to the numerator if it was in the denominator. Negative exponents, they move your fraction or whatever part of the fraction into either the numerator or denominator in order to switch the sign. You have to remember that. Okay, next one, log of 1,000. So this would be 10 to the x equals 1,000. I know that that would have to be x equals 3. Okay, if you're having trouble with these, you do need to go back and you need to memorize all of the basic exponential stuff like 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth, 2 to the sixth, 3 to the third, 3 squared. You really should know all the basic ones. If you don't, you're going to run into trouble. Okay, lots of negative numbers do not exist. So if I take the log of this or the log of this and I plug it into my calculator, you'll notice that it comes up with an error and it'll say non-real. That's because they don't exist. Okay, so I'm just going to say that those are both non-real. Okay, next up, I want to solve these equations, so I'm going to put them in the exponential form so that I can solve them. So if I have log of a equals 2, that's the same thing as saying 10 to the 2 equals a, which means that a equals 100. Okay, this one here, I've got 10 to the negative 3 equals b. 10 to the negative 3, that's the same as 1 over 10 to the third, which is 1 over 1,000. Okay, log of g equals 5.1. That's 10 to the 5.1 equals g. If I plug that into my calculator, I get this. Okay, log of x equals 1.5. That's just 10 to the 1.5 equals x. Okay, 10 to the 1.5. If I plug that in my calculator, I get 31.6228. Okay, last thing, true or false. The logarithm of 1 is 0. Well, let's think about rewriting that. So if I say log of 1 equals 0, that's the same as saying 10 to the 0 equals 1. Is that true? Yes, that is true. Anything to the 0 power equals 1. So the domain of the common logarithm function is the set of real numbers. Well, could I plug in any value into a logarithm? The answer is no, you cannot plug in negative values. So I'm going to say false because I can't have negatives. Okay, logarithm of negative 6 does not exist. That's going to be true because I know that if I plug in a negative number into a logarithm, I get a non-real answer. And that's everything for section 5.